Okay, this is the last video, and I just want to highlight a few things. Really, it's just the last bit here, which is talking about cost. So we've been talking about pricing in the last two videos, but really this is almost just the last one that we need to talk about, is this idea of the cost function. And it's actually quite a straightforward function, and we've come across it quite heavily. We are aware of the relationship between total cost, and we know that that's made up of a fixed cost and a variable cost. And that fixed cost is what's referred to as A. So if you like, as you've seen it with break even, everything we've been doing so far, that's your fixed cost starting there. And typically we argue that the variable cost, the cost varies with output as we keep on making, as we keep on increasing that. As we keep on making output, we have the costs going up. So we have costs, of course, fixed costs and everything else, of course, becoming total cost made up of variable and fixed. We just don't record. We don't typically draw the variable cost into our picture. So, so the key point is, once we know one of them, we can predict. The whole issue here is our ability to predict what future costs will be. If we know what the fixed costs are, we know that something is variable, right? So there is a relationship, really. It's just highlighting that relationship and applying it. So where y is equal to a plus bx, so we're arguing again that there's a gradient here. This b here is really the argument that what does the cost increase by with every additional unit. So if I make a unit of output, what does cost increase by? And so that's the relationship. That's what b is. So a is fixed cost and b is the variable cost per unit, if you like, referred to as the gradient. And of course x is the activity, of course the independent variable, and of course the fixed cost, the total cost here is on this side, which is fixed cost plus variable cost. Yes, let's do an example. I need to pull out an example. I'm just going to do one on the, and you can't see it, but when I say an example, I'm just going to kind of highlight what I'm trying to say here. Because what you have, I mean, really, I think I should have used. It does, again, like I say, it doesn't really matter. I think that the key point is that it's like saying, I think, for example, if you see something that looks like this, that y is equal to 5,000 plus 10x. Well, all this simply means is that we have a fixed cost of 5,000, and we know that for every unit we produce, the variable cost is £10. So we know that the direct materials, direct labor, is £10. We know that, therefore, this is the slope. I mean, again, you could be given 2 points on the curve, and all you would do again, so you, for example, you could get y, if you're trying to find, you might be told something like the total cost of something is 5 for making I don't know, whatever, 100 units. The total cost is 5,000, and then the total cost of making 120 units is 5,000, I don't know, 200. And so you'd use simultaneous equations. So basically, again, what you have here is you have 5,000 is equal to fixed costs plus, if you like, 5,000 times the variable cost. And here you have 5,200 is equal to fixed costs plus, if you like, 100. Here it was 100 times VC, and here is 120 times VC. So we would use simultaneous equations, again, like we've just done before, to get rid of that, find the variable cost, plug it in. So it's really about being happy and flexible, but being aware of the curve. So once you have a curve, you can happily move along and do different things. But it's just being very happy with this relationship, and the rest is just simultaneous equations. You're either finding fixed costs and then variable costs, and then once you know these two, you can go in and plug it. You go in and plug in for it, and you can go in. Someone could ask you, okay, what about some other units? What about 300 units? Well, I know fixed costs and the variable costs. All I have to do is plug that in, right? Which is what you would do if you're given the fixed cost of 5,000 and you're told that the variable cost is 10, and you're asked what's the total cost, well, you'd multiply 10 times 300, which is 3,000, and you'd add that to the 5, and you'd know your total cost therefore was 8. So that's kind of what's really happening here. So I mean, again, so really it's for you to just throw yourself into some of the questions in the kit, if you like, especially in this area, because then it sort of gets a bit more creative, but not just from a mathematical point of view, not from a conceptual point of view. If you like, saying, oh, what if we give discounts after a certain number of units? So you know the equation. It's just playing around with something. And that's what we'll be doing, playing with questions. But this is just to give you a foretaste of really what that is. The rest of the chapter ends talking about pricing strategies. I didn't even make any notes on them, but fundamentally they want you to be happy with the idea of market penetration and market skimming. Please read these. Market penetration, you're literally dropping your price to gain access to that market. Market skimming, you have a willing and tribal sort of product, so you know that you have, if you like, early adopters who will happily buy and pay a premium for the product, so you'll be able to sell it to them at that higher price, and they'll be happy to pay for it. So you do that, and that's what you do there. You don't drop the price in that scenario. You would you will sell it to them, whatever it is you want to sell them, because you know they'll pay. Cool, great stuff. And that's chapter 5 done. Please read through the chapter, but these are just notes to just kind of help you cement that your understanding. And we'll spend time in class just powering through as many questions as possible to see application.